Good morning all. I am Praveena, working as Assistant Professor in Department of Information Technology, BVRIT Narsapur. Today I am going to explain about data structure topics. Now we shall discuss the types of linked list. So what are the different types of linked list means? Single linked list, doubly linked list, circularly linked list. Now let us see what is singly linked list. Singly linked list, a single or simply a linked list is linear collection of data items. That means here the data items are present in a linear fashion. The linear order is given by means of pointers, means which pointer is nothing but which stores the address of another node or element. These types of lists are often referred to as linear linked list. So singly linked list are also called as linear linked list. Each item in the list is called node. And each node of the list has two fields. One field is information field, the another field is next address, means pointer field. So information field, what it contains? It contains the item being stored in the list. Whatever the item that we have to store in the list, that information is present in the information field. And in the case of next address, it contains the address of the next item in the list. Whatever the element that is present in the list to the next, the address is present in this node. So the last node in the list contains null pointer to indicate that is the end of the list. Let us see it in a diagrammatical manner. So this is the diagrammatical manner of the singly linked list. So here this picture, it shows the node. It containing two fields. The first field is data field and the second field is pointer field. So it represents the single node, and the singly linked list, it is containing multiple nodes. Each node is containing two fields. One is data field and the next field, it contains the pointer to the next node. Likewise, all the nodes are having two fields. The first field, it is representing data field and the next field, it is representing the pointer to the next node. So on. So here we are having multiple nodes. And here the last node, it is pointing to null. Null is nothing but there are no more nodes in the list. So let us see the operations that are performed on singly linked list. So the first operation is insertion of a node. Second operation is deletion of a node. Third operation is traversing the list. Now let us see the first one, the structure of a node. So we have seen diagrammatically the structure of a node. This is the structure of a node. So node contains two fields, I told. The first field is data field. The second field is address of the next node. Let us see this in the programmatical, in the code form. So here this shows the structure of node. So method 1 and method 2 that are used to represent the node. So here I am using the structure in order to represent the node. Already we are familiar what is a structure. Structure is a collection of heterogeneous data items. That means it is different from array. Whereas in array, it is a collection of homogeneous data items. Array. That means there it should have only the data which is of similar type. Whereas in the structure, it may contain the data of different data types. See how the structure is represented. So we can write the structure by using the keyword struct. Struct is the keyword here in order to write the definition of the structure. And here node. So in the place of this node, we can write whatever the name we feel comfortable. Not only the name node is written here, we can write another name also, like suppose I feel like writing some S, T, N, whatever it may be, not only single letter, different group of characters that use a name to the node can be written as the variable name. As the variable name, it contains a collection of characters, digits or underscore. Likewise, we can give the name of the structure as our necessity or as our wish. So the structure, it is containing two data, two fields here. The first field, it is the data, which represents the first field in the node. So here I am representing the data in the form of integer type. If we want to represent the data in float type or double type, we have to mention the data type of the data here. So, and here link, asterisk means it represents the pointer. So I have given the name of the pointer as link. So this, it represents this field. So the diagrammatical representation of this node is represented in the form of code. So the first field, it represents the data. So the data is written in the structure. And next, the struct node asterisk link means it represents the pointer to this link. So struct is the keyword which is used to represent the pointer. Now let us see method 2. So in the method 2 also we are having data type of integer type. So here data is of integer type, and here also we are having the node of link, and instead of writing this in the structure directly, here we are creating a class, structure class. So here class node public. So we are familiar with access specifiers either in Java or C++. We are having three access specifiers. One is public, private, protected. So if in front of any integer or in front of any method or in front of any class, if I declare it as public, then it defines that, it indicates that data, method or class can be accessed not only in the method or class which is declared, it can be accessed outside the method also. So here the data is declared as public. It indicates that this data is accessed not only within this structure, it can be accessed from outside of this class which represents this class. Not only this class, this data is accessed outside of this class also. So here also I am creating a link pointer. So remember that here we have two fields for the node. So one field, it represents the data, the second field, it represents the pointer to the next node. So single linked list is nothing but it is a collection of nodes, and each node contains two fields. One field is data, another field is pointer to the next node. So we can insert the data or node in three ways. So in the linked list, we can insert the data first at the beginning or at the end of the list or at the given position, wherever the desired position. Now let us see how the data is inserted at the beginning of the list. So already we have a list here. So the single linked list is already present in the diagram. So here we are having different nodes. So each node is containing two fields, and the first node is containing the data as 10, the second node is containing the data as 20, and the third node is containing the data as 30, the fourth node it is containing the data as 40. So always the first node it is pointed by head. That means the first node is head node. It represents that this is the first node in the list. Now suppose I want to insert this node which is containing the data that is 50. So this node I have to insert at the front of this list. So first of all, what I have to do? First, I am making this node as temporary node. So here I am considering this node as temporary node which is represented here. Now let us see how it is inserted first. So I discussed head is the pointer variable. So you are already familiar what is pointer variable, which contains the address of another node. So here head what it is containing? It is containing the address of the first node as the diagram represents. So head is the pointer variable. What it is containing? Pointer is nothing but it contains the address. Whose address is present in this list? Head is containing the address of the first node. So the temporary contains the address of the new node to be inserted. Then let us see the sample code for this. So the temporary, it contains the address of the node that has to be inserted. So for this purpose, what I am making? I am making the address pointer of temporary node to point to the head. That means I am storing the address of this temporary node in head. So now head node, temporary node has become the head node. So we have made the inserted the element 50 as first node. So let us see the previous diagram. So this is the actual list, and here this is the node that has to be inserted. So for this purpose, what I did, I made the pointer of temporary node to point to head. That means I am making the head pointer variable to point to the temporary node, and now the temporary node is stored in the head. That means the address of this node is stored in the head. So the head pointer variable is pointing to the first node. So automatically the element is inserted at the beginning of the list here. So this is the actual list that is present earlier, that is 10, 20, 30, 40. So now newly inserted node is 50, and we are making the pointer variable head to point to the node that is 50, which is already stored in the temporary variable. And we have to remember one thing, that the last node should point to null. That means it is not pointing to any other nodes. It indicates that this is the last node. Now let us see the code in order to insert at the front. So to insert the code at front, so here I have written template class T. So here the name of the class is template I have given, and T is the variable which indicates that any type of data can be stored in the list. So remember that T, capital T, it represents that this list can contain any type of data variables. So here void list, this is the name of the list, and insert front. So insert front is nothing but the name of the function which is accessed in the list. And here we are having the list. So first struct node. I already shown you how to write the structure which contains the heterogeneous data items, which is containing two data. One is data and another one is pointer. So struct node. and t. Here we are declaring two variables, pointer variables. One is asterisk t and another one is temporary pointer variable. Now let us see. Cout is nothing but the output statement in the C++. Here enter data into the node. It is asking to enter the data into the node. Whatever the data that is given by the user, that is stored in the variable that is item. So for this purpose we are having the function cin. Now let us see temp equal to create node of item. So what we are doing here, we are creating a node. So that node is containing item, and where this data item is stored in the temporary variable. So if head is equal to null, head is equal to null means here head, the pointer variable head, I already told you head is nothing but the pointer variable which is pointing to the first node in the list. So if head is equal to null means what? The pointer variable head is not pointing to any node. That means there is no node in the list. That means the list is empty. Now let us take already the variable, temporary variable, we are having one item here, data item. So that temporary data item or the variable that is present, that data that is present in the temporary variable, it is assigned to head. That means the pointer variable head. We are assigning the value that is present in the temporary variable, that is assigned to the pointer variable head. Else means if there are elements in the list. So the first case we have seen that if head is pointing to null means here there are no nodes. That means the pointer variable head is not pointing to any node in the list, means the list is empty. The second case, what is the second case? Temporary link equal to head. That means if there are elements in the list. So in this case what will happen? We are making the pointer variable head. It is pointing to temporary variable. We are making the pointer variable head to point to the temporary variable which we have stored here. So automatically the data item that is present in the temporary variable will be assigned to the pointer variable head. So here we inserted the element at the front. Why? Because we are making the pointer variable head to point to the temporary variable. Now let us see the second case. So in the second case, so already we have seen the elements that are present in the list are 10, 20, 30, 40. Previous we have seen. So earlier we have inserted the node at the beginning. That is 50 has been inserted at the beginning and we made the pointer variable head to point to the node that is which is present. 50 is present here. Now I want to insert the node which is having the data that is 60. It is to be inserted at the end of this node. Here I have to insert. So for this purpose, let us see what we have to do. So initially in the previous case, as we inserted the node at the beginning, there we have made that node as temporary node. So head is the pointer variable which contains address of first node and temporary contains the address of new node to be inserted in the sample code, which we have discussed in the previous case, that is where we have inserted the node at the beginning. Now let us see the sample code which has to be used in order to insert the node at the end of the list. So here what we are doing, already we have declared a pointer variable t. So what we are making the pointer variable head to point to t. The address of pointer variable head is stored in the variable pointer variable, that is t. Now while t link is not equal to null, that means the head is not equal to null, means it is pointing to some nodes in the list. It represents here that the list is not empty. If head is equal to null means the list is empty. If head is not equal to null means the list contains some sample nodes in the list. So here what I am doing, I am making the pointer variable t, the address is stored in the element, that is t, and the temporary variable address is made to point to t here. So after insertion, how the linked list will be there? For this we shall write a code. So code for inserting at the end. So here we have seen in the previous case how to insert the node at the front. Now we are seeing how to insert the node at the end of the list. For this we shall write a sample code. So in the previous case I told, here I am writing a class name as template. So here the variable capital T, it represents the data. Any type of data can be inserted into the list. So here I am creating the list. So void list insert end. So here I am using the function insert end function in the list. In the previous case I have used insert front function in the list. Here I am using the function insert end in the list. So here I am declaring the pointer variables. T is a pointer variable and temp is a pointer variable are declared for the structure. And here I have declared a variable, that is n. So here I am asking a print out function, that is output function, enter data into code. With the help of cout function in the C++, we are asking to enter the data to the code. Now cin function means this is the input function in C++. Here by using the variable n, whatever the value that is given by the user, where it is stored, it is stored in the variable n. Now here I am creating a node of data. Which data is present? The data that is given by the user, which is already stored in the variable n. So this created node, newly created node is stored in temporary variable. So if head is equal to null, what does it indicate? It indicates that the head pointer is not pointing to any node in the list. That means the list is empty. Head is equal to temp. So already in the variable temporary variable, I created a node and it is stored in the temporary variable. So this node is indirectly assigned to the pointer variable head. So if the head is equal to null, so that means if the list is empty. In this first step, I am creating a node and I am assigning this node to temporary variable. And from the temporary variable, I am assigning this node to head node. This node itself becomes head node. Why? Because already the list is empty. Else means if the elements or the nodes are present in the list. In this case, what we have to do? We are assigning this head pointer variable to the temporary pointer variable, that is. Now, while t link is not equal to null, that means if the head pointer variable it is not equal to null, that means there are some elements in the list. If there are some elements in the list, so in this case I am assigning the value, that node that is present in the temporary variable, it is made to point as head node. So now let us see the third case, inserting at a desired position. So instead of inserting at front or end, I want to insert the element somewhere in the middle in the desired position. So now my intention is I have to insert the element 60 somewhere in the middle. Here I have given to insert the node at the position 3. So head is the pointer variable which contains address of first node, which we discussed in the previous slides, and temporary variable contains address of new node to be inserted. Then sample code here is, so after insertion, so in the third position, so index here is 0, 1, 2. So in the third position I insert the node that is 60. So for this, the sample code is same as we have discussed in the previous cases in order to insert the node at front, end. So similarly, I have written a code for the inserting the node somewhere in the middle. So in somewhere in the middle, which position I have chosen here means third position. So same code, template is the class name, capital T is the variable which indicates that any type of data can be inserted into the list. So here I have created a list which is containing the method that is insert at POS means here position, int POS means position. So whichever the position I require, here I have taken position 3. This is the variable name and this is the method name. So here in the list I have created the structure, struct node. So capital T, here I have created 3 pointer variables. In the first case I have created temporary variable, pointer variable, and in the second case I have created 2 temporary variables, pointer variables, that is one is temp pointer variable and T pointer variable. Now I have created 3 pointer variables. CUR means current pointer variable, PREV means previous pointer variable, TEMP means temporary pointer variable. So here I have C means here count. So initially the count value is 1. Now T item means the item is of type capital T. Capital T means any type of data can be inserted into the list. C out means it is the output function. It is asking to enter data into the code. C in means it is the input function. So whatever the value that is taken from the user, it is stored in the variable that is item. So here I am storing the node, creating the node, I am storing the node into the temporary variable. So here initially I am taking the assumption that head is equal to null. If the head is equal to null, what we have to do? The position will be 1. That means the node has to be inserted at the first position. And the pointer variable temporary will be pointed to head. Else, so if the list is not empty, so C out, it is the output function, position out of bounds for an empty list. Suppose I have given the list as the 3. So if the position out of bounds empty list means, so list is empty. So here it is ended. Next, delete temp. So here we are deleting the temporary node and we are returning the list. If the position is equal to 1, then we are making the head pointer variable to point to temporary variable and we are returning the node. So now we are making the previous pointer to point to the current node and we are assigning this as head node. So while C, already I have given a constant value, initially I have given as 1. So if C less than POS means position, here we are seeing 2 conditions. One is the constant value C should be less than POS and current pointer should not be equal to null. So here I am making the previous pointer to point to the current node, and I am making the current node to point to the link. Current link is the new node that is added in the list, and the count value will be incremented. See, plus plus means initially we have given the count value as 1. As now I inserted one node, so the count value is increased to C plus plus, C equal to C plus 1, 1 plus 1, 2. So if C less than POS, second case, next case, so position out of bounds. So we cannot insert the node. So we have to delete the temporary node. Else we are making the previous node link pointer variable to point to the temporary node which is already having the node which is created newly, and we are making the pointer variable of temporary node to current pointer variable. So these are the three cases where we can insert the nodes in singly linked list. Insert at the beginning, insert at the end, insert at the middle of the list. So we discussed today list ADT. Here list we have discussed about single linked list which is having operations such as insertion, deletion, traverse. In insertion we are having three cases. One is inserting at the beginning, inserting at the end, and inserting at the somewhere in the middle of the list. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.